Assalamualaikum warahmatullah. Bismillahirrahmanirrahim. Okay, we continue our presentation in chapter 2, analog modulation. Amplitude modulation, it is often necessary to transmit the signal from one place to another. These signals are normally transmitted over a transmission line or open space, but many signals are transmitted simultaneously. If these signals lie in the same frequency band, then they will interfere each other. For example, if multiple speakers are talking on the same telephone line, then their voice will mix up. Similarly, if multiple television stations are transmitting in the same frequency band, then their signals will interfere each other. Therefore, necessary to translate the frequency band of every source, such as that they occupy distinct band of frequencies. Sometimes the signals are transmitted in short time slots. Each source occupies fixed time slot. Frequency translation is possible with frequency division multiplexing. Time division multiplexing offers fixed time slot to each source. Modulation techniques also perform frequency translation. Signals are transmitted between a transmitter over some form of transmission medium. But normally signals are not in the form that suitable for transmission and need to be transformed. Modulation is a process of transforming this signal. So the process is impressing or applying low frequency information signal. This low frequency information signal. This is the information signal, modulating signal, low frequency, onto a relatively high frequency carrier signal. So this is carrier signal, low frequency information signal, high frequency carrier signal, using a device called modulator. So will produce modulated signal. So this is modulated signal. Okay, so in layman terms, we plus the carrier and the modulating signal to produce modulated signal. And for amplitude modulation, the signal is in the form of envelope, as been shown previously. Principles of AM, amplitude modulation. Amplitude modulation is the process of changing the amplitude of a relatively high frequency carrier signal with the instantaneous value of the modulating signal. Instantaneous value or amplitude value. Instantaneous amplitude value of the modulating signal, aka information signal. There are two inputs to the modulation device, which is known as modulator. Two inputs. First is high frequency carrier signal with constant amplitude, and second input is low frequency information signal that may be single frequency or complex waveform made up of many frequencies. Okay, this is two inputs of the modulator. In the modulator, the information signal modulates the RF, radio frequency, high frequency carrier signal to produce a modulated waveform made up of many frequencies. This modulated waveform is called AM envelope, amplitude modulated signal envelope. Okay, so this signal, the modulating signal, low frequency signal, FM. M N stand for modulating, FM. So we have VM here, VM, the amplitude of the signal, VM, and low frequency, the frequency is FM. This is the modulating signal. Another one is carrier signal, VC. C stand for carrier, VC, and FC. So FC is the frequency of the carrier. So we have this high frequency carrier signal. Okay, so by combining these two signal, modulating and carrier, will produce AM envelope. So this is envelope. What is this? This is modulated wave, AM modulated wave. So VAM, and this is envelope. So you can see that the amplitude changes. So this is the envelope, AM DSBFC envelope. Amplitude modulated double sideband full carrier, AM DB DSB FC. Amplitude modulated double sideband full carrier envelope. So the signal, actually this part, the signal will vary the amplitude. Amplitude of the signal varies according to the amplitude of the modulating signal, but the frequency of the signal constant following the value of the frequency of the carrier. Okay, so this carrier plus, this modulating signal plus the carrier signal produce envelope, AM signal, AM modulated signal. Next, so this is another example how the signal combine and become AM wave. So this is the low frequency modulating signal, FS, and this is high frequency carrier signal, FC. This combined together in the process of AM modulation and producing AM envelope. Okay, so we can see here the envelope of the signal. Actually, the signal is the one that is green here, and the red line, line here is imaginary line to show that it is in the form of envelope. Okay, the application of amplitude modulation normally for radio broadcasting, TV picture, facsimile transmission. This is a common example of amplitude modulation. So we have radio broadcasting, AM radio broadcasting, TV, and also fax. So amplitude modulation operate in the frequency range between around 500 kilohertz up to 1.6 megahertz, or we can say from 0.5 megahertz up to 1.6 megahertz, or 500 kilohertz up to 1600 kilohertz, and it normally has bandwidth about 10 kilohertz. So we can see the bandwidth is quite small, 10 in the range of kilohertz. So the application, the frequency range and bandwidth. So here normally the range is in kilohertz, hundreds of kilohertz, or only around 1 megahertz. Okay, AM envelope. Principle of amplitude modulation. The modulating signal modulate amplitude, frequency or phase of the carrier according to its variation in amplitude. This result in amplitude and frequency of phase modulation. Frequency and phase modulation is also called angular modulation. AM envelope and equation of AM wave. So now we will see further. We will discuss further about the theoretical equation, how the AM modulation process in terms of mathematical equation. So let's say this signal is modulating signal with amplitude, with the maximum amplitude EM, and FM is the frequency. And let's say this carrier signal is the signal with maximum amplitude EC and FC frequency. So combine this, we will have this amplitude of modulated signal, AM modulated signal. Let us represent the modulating signal by EM, and is given as, so this is the sine wave equation. EM equal to EM, the amplitude, sine omega m t, and the carrier signal can be represented by EC equal to EC, maximum amplitude, sine omega c t. Here EM is the maximum amplitude of the modulating signal, EC is the maximum amplitude of carrier signal, omega m is the frequency of modulating signal m, omega c is the frequency of carrier signal. So using the above mathematical expression for modulating and carrier signal, we can create new mathematical expression for the complete modulated wave. It is given as the amplitude modulated signal is the carrier plus the modulating signal. It's only the addition process, plus process, EC plus EM. So putting the equation into this equation, the instantaneous value of the amplitude modulated wave can be given as EM. So this is the instantaneous value of the amplitude. This is the equation for envelope. AM envelope modulated signal. So AM signal, the envelope is this is the amplitude and sine omega ct. So we can see from this equation that the amplitude of the envelope, the amplitude modulated signal, the envelope has the amplitude with the value of EM, with the value of this is the modulating signal, and this is, so this envelope has the frequency of carrier signal omega c, but the amplitude of the envelope keep changing due to the change of this modulating signal. So that's all. The equation for the envelope is EAM equal to EC plus EM sine omega mt, amplitude part, sine omega ct. So the signal has constant frequency, which is the same with the carrier frequency. So that's all. We will continue after this. Thank you very much.